Season 2 of the Code Like an Architect series, Abstraction in Action.
So far in this season, we have seen the big picture of abstraction and explored 100 real-life examples. In this video, we will explore abstraction in programming. We will see abstraction at method level, at object level, at project level, and at architecture level. We will see that abstraction is everywhere. And as developers, we use thousands of abstraction every single day and make our life much easier, often without even realizing it. First, what is abstraction? As we have already seen in the big picture, two entities need to communicate. If they interact directly, that's not abstraction. But if they use an interface as an intermediary while keeping the entity being called hidden, that's abstraction. Abstraction is the act of hiding the underlying details. There are three elements in an abstraction: user, interface, and implementation details. Now let's begin with some very basic forms of abstraction in programming. Have you ever called a method? Inside a method, we have a body. That's the internal implementation. We also have a definition that acts as the interface of the method. And finally, the code that calls this method. That's the user. Is this an abstraction? Let's find out. Abstraction is the act of hiding the underlying details. In this case, the implementation details of the method are completely hidden from the calling code. The calling code only relies on the definition. It knows nothing about the body. So yes, this is an abstraction because it's hiding underlying details. Let's keep exploring. Is there a user? Yes, the code that calls the method is the user. What's the purpose? The purpose of having this method definition is to enable and facilitate the interaction. Here, the definition is present so that the calling code can use the method. And that definition must be designed according to the needs of the calling code. The definition serves as an interface for the calling code, and it also separates what from how. So, for example, when we call methods like print something or get balance or calculate distance, we are interested in what we want, without needing to know how the method actually does that. Let's keep going. Do methods support multiple interfaces and multiple implementations? Not directly, but you can achieve this manually. For example, you can create multiple interfaces through method overloads or by using optional parameters. Similarly, you can manually create multiple implementation for the same definition. They also provide all the key benefits of abstraction, including reduced complexity, because no matter how complicated the implementation is, we interact with a simple interface without ever dealing with the details. To some extent, generalization and swappability, as we can keep changing the implementation and we can conditionally choose which implementation to use. Extensibility, because we can build on top of existing abstractions. One method can call another, which can call yet another, and so on. That's extensibility, as we are building on top of existing abstractions. And maintainability, because we can change the internal logic of a method without needing to make any changes in the code that calls it. A method is the most basic and also the most widely used form of abstraction. That's why it's so important to design your methods thoughtfully. Let's move forward. In object-oriented programming, the basic unit of organization is not a method, but an object. And an object in turn comprises attributes and methods. So you still have methods. But when you design abstraction in OOP, you think more in terms of objects than just methods. So in OOP, abstraction looks like this. You have two classes which need to interact and an interface to facilitate the interaction. That's abstraction in OOP. You might already be aware of it. But before we go further, let's take a step back and look at this more conceptually. We'll walk through a scenario to see how we logically arrive at the idea of an interface. So look at this class. It has the functionality to serialize and deserialize. But no other class can call this functionality. Why? Because it has no interface. Both methods in this class are private. That means the class doesn't expose any way for other classes to interact with it. The class has a fully working functionality, but there is no way for other classes to use it. Now, if you make those methods public, it now has an interface that other classes can use to interact. So, the signatures of all public members of a class taken together form an interface that other classes can use to communicate with it. It defines how other classes can interact with this class. And the bodies of the public members, along with all the private methods, are internal implementation details. We already learned that abstraction has a user, an interface, and implementation details. In this setup, this is interface, and this is implementation, both combined within the class itself. And any class that interacts with this is the user. If you have watched my previous videos and you are conceptually sound, you can definitely use this setup to achieve abstraction in OOP. You will need to carefully decide which methods should remain private and which ones should be public. And you will also need to design the definitions of your public methods thoughtfully. With these careful consideration, you can absolutely use a class to implement abstraction. But there are a few problems and limitations. When the interface and the implementation are combined inside a class, it creates issues. Let's see. When interface and implementation are in the same place, they can easily get mixed up. For example, a developer might accidentally mark a private method as public, or worse, they might ignore access modifiers altogether. Some even make everything public by default. And in that case, details that were meant to stay hidden end up being exposed to other classes, breaking abstraction. It discourages thoughtful design. When the interface and the implementation live in the same place, developers often can't clearly distinguish which parts belong to the interface and which are implementation details. When everything is mixed physically, it becomes harder to separate concerns conceptually. It sacrifices the benefits of abstraction. When the interface and implementation are tightly coupled, you will lose the ability to use multiple interfaces and multiple implementations. As a result, most of the flexibility and power that abstraction offers and that we have witnessed in 100 real-life examples of abstraction will be lost. Due to these reasons, different programming languages, including C# and Java, provide a built-in construct called interface. With this interface construct, we can design the interaction layer of a class separately from its implementation details. And this makes a huge difference. We no longer have to rely on the public members of a class to define its interface. This way, we don't lose the benefits and flexibility that abstraction offers. So now the roles are clear. The class provides the implementation details, which stay hidden from the user, and the interface defines how we interact with it. The interface is all about interaction and communication. That's exactly why it's called an interface. Meanwhile, the class is responsible for handling the actual implementation details behind the scenes. This means the interface should be exposed to other classes for interaction. And it also means the class itself should remain hidden from the classes that use it. This point is very important. Many developers who use interfaces don't pay enough attention to actually hiding the implementation. So let me stress this again. Any class that wants to interact should do so only through the interface, without even needing to know which class is behind it. And once again, this makes a huge difference. Let's understand this with a coding example. First, let's set up some projects. Demo.business, demo.interfaces, demo.implementations. Now, inside the demo.interfaces project, we will create an interface called iSerializer. Next, in the demo.implementations project, we will create a serializer class. This class needs to implement the interface, so I will add the reference of the demo.interface project here. This class will hold the actual implementation detail of serialization and deserialization. After that, I will configure dependency injection. And finally, here's the class inside the demo.business project where I need to use serialization. Right now, the business project does not have the reference of demo.interfaces and demo.implementations project. This means it has no knowledge of the classes inside those projects until I add the references of those projects. Now watch, I will only add a reference of demo.interfaces. Then inside this class, I will use the interface. Of course, I will need to add the proper namespaces, adding code. Notice that I never added a reference of demo.implementations, the project that actually contains the serializer class. So what does this mean? It means the business project knows nothing about the serializer class, the class that has the actual implementation. All it's aware of is the interface. Now let's run the project and see what happens. Now, this line will call the serialize method. Let's see where it goes. It landed inside the serializer class in the demo.implementations project. Interesting. Did you notice something? This class has no knowledge of the serializer class. It doesn't even include its namespace. It doesn't even reference the demo.implementations project. And yet, it was able to call it. That's abstraction. The class only knows about the interface. All of its interaction happens through that interface, while the real implementation stays completely hidden. even without a single reference, even without any awareness that some serializer class even exists. This class still ends up calling it. That's abstraction in action. It's highly loosely coupled. Of course, how can a class be coupled with another class if it doesn't even know that it exists? This makes your code more maintainable, generic, less complex, reusable, extensible, and reliable. I won't dive into the details of those benefits in this video. We will explore them in depth in the upcoming videos. For now, just remember this. Abstraction is the most fundamental concept that you need to master to code like an architect. So far, we have seen abstraction at the method level. Then we saw it at the object level. And you might have noticed we also used abstraction at the project level. By carefully placing objects in different projects, we turned projects themselves into a tool for abstraction. Next, in the same way, we use abstraction at the component and architecture level. For example, when you create an API endpoint in a client-server architecture, you're creating an interface that the client uses to interact with the server without knowing the server's internal details. Similarly, in a distributed architecture like microservices, each service provides a layer of abstraction. See, abstraction is everywhere. And when I say everywhere, I literally mean everywhere. Let's see. In the 100 real-life examples of abstraction, we saw that as humans, we interact with thousands of abstraction every single day. And as developers, it's no different. As developers, we too work with thousands of abstraction every single day. Just think about it. Every time you use a library or NuGet to use an existing functionality, you use an abstraction. Think of a maths library. You use the methods to get results without knowing the underlying calculations, or a serialization or encryption library. All of them are abstractions. Every time you use a framework, whether it's for web, mobile, or desktop app development, you're relying on abstraction. Each one of them wraps thousands of abstraction inside them in the forms of methods, classes, interfaces, events, and so on. You use them without knowing the implementation details. Every time you write even a single line of code, even as simple as an initialization or an assignment, you use abstraction. Think about it. When you write this line of code in a high-level language like C#, it triggers a whole chain of actions under the covers. It allocates memory, assigns an address, checks for type safety. It starts reading from the address of B, determines how many bytes to read, and then copies the value of B to the address of A, and more. Every line of code that you write hides inside many layers of abstraction, and each of those layers may have multiple abstractions involved. Hopefully, this helps you realize how abstraction makes our life easier by hiding the complexity in underlying layers and by giving the ability to build on top of those layers. We already saw in 100 real-life examples of abstraction that abstraction is not just a programming concept. It's present in almost every discipline, right? It's also very important to understand that even in programming, it's not just an object-oriented concept. It's present everywhere, from hardware to operating system, from the tools that we use to the code to the architecture and to the cloud. Abstraction is everywhere. The keyboard that you use to type is an abstraction. The operating system is an abstraction. The code editor that we use provides abstraction. How? It's a feature-rich interface that facilitates us to write code efficiently on the underlying files. Every time you press the run or build button, you use an abstraction. Think of GitHub. You don't have to understand the complex version control system. You don't have to know how Git stores objects, manages references, or handles branching internally. No, you can use simple commands or a web or desktop interface to interact with your repo. Every time you use Google or YouTube or ChatGPT, you use abstraction. Just think about it. You interact with a simple chatbot interface, but behind the scenes, a complex AI system is working, processing language, understanding context, and generating meaningful responses. Abstraction is literally everywhere. Think about a database management studio. That's a user-friendly interface that allows you to create databases, manage a schema, read and manipulate data, and do other administrative tasks. Think of a SQL query. The actual data is stored in the files. SQL gives you a user-friendly interface to interact with data without worrying about interacting with the files directly. Abstraction is everywhere. Come up with any design pattern name. You find abstraction in almost all of them. You will hardly find an architectural pattern or style that doesn't have the concept of abstraction involved in one way or other. Think of the layers in the three-tiered architecture like business layer or data access layer, be it clean architecture, hexagonal architecture, web queue worker, microservices, be it messaging, APIs, GraphQL, SignalR, be it repository, abstract factory, observer, facade, Abstraction is present at the most fundamental concept in everything. That's why abstraction is such an important idea to grasp. And I hope you can now see why I dedicated an entire season to abstraction. Abstraction is a common fundamental concept found almost everywhere. Yes, every principle has its own details, benefits, and unique importance. And yes, there are many advanced ideas you will need to learn on your journey. But having a strong grip on abstraction gives you the foundation to understanding all of them. That's why I believe mastering abstraction and truly learning how to apply it in practice is one of the most important steps towards becoming an architect. It sets the stage for everything that follows, and it prepares you for the advanced concepts that every aspiring architect must strive to master. So remember, when you master abstraction, you unlock the door to architecture. Next, you already know abstraction is important. You know it's everywhere and you have started using it. But here's the catch. Many developers use abstraction because they know it's important, yet they never see the real benefit. For example, they use interfaces, but still find themselves making changes every time something new comes up. They don't notice any big difference or don't get the practical benefit. Most of the time, this happens because they don't truly understand how to design abstraction. And here's the truth. A poorly designed abstraction is no better than having no abstraction at all. In fact, sometimes it's even worse. That's why it's absolutely critical to learn how to design abstractions the right way. And for that, we will need to study the abstraction design principle. Watch the next video.